Hey everyone, let's solve problem 2, part A. So consider a reflection of electromagnetic wave with frequency of 80 GHz incident from vacuum onto a good but not perfect conductor such as calcium, which has sigma equal to 2.98 into 10 to the power 7 Siemens per meter. Write down the expression for fraction of power which is reflected as a function of the complex impedance. So we begin by drawing first the two mediums. Let us say this is eta1, this is eta2, this is vacuum, this is calcium. We know that the eta1 is the impedance of vacuum, which is 377 ohms. We have to find what eta2 is, but more importantly what we have to find is the expression for fraction of power which is reflected. So basically we have to derive the equation R is equals to eta2 minus eta1 divided by eta2 plus eta1 whole square. So remember, this is the expression we used in the first problem. We are supposed to derive this right now. So how do we go about doing it? First we find the expression for eta2, then we find the expression for gamma, and then we find the expression for R. Okay, so these are the three steps that will be used. So how do we find eta2? Eta2 is equals to square root of mu2 divided by epsilon 2. We know eta2 is complex because epsilon 2 is a complex number. So mu2 is mu naught because the material is non-magnetic. Therefore eta2 is equals to square root of mu naught divided by epsilon dash minus j epsilon double dash. What is epsilon dash? That is equals to epsilon, which is equals to epsilon naught epsilon r. Epsilon double dash is equals to sigma by omega. We make the substitution, mu naught divided by epsilon minus j sigma by omega. So let's try a simplification here, which is equals to divide both the numerator and denominator by epsilon. That is going to give us mu naught by epsilon divided by epsilon, which is equals to 1 minus j sigma by omega epsilon. So because epsilon is very less than sigma by omega in this particular context, we can ignore the 1 in the denominator and rewrite the expression as eta2 is equals to square root of mu naught divided by epsilon divided by minus j sigma by omega epsilon naught epsilon. So this is going to become, we can send the j upwards with the minus sign and make it a positive j. So it's going to be j mu naught divided by epsilon into sigma into omega epsilon square root of the whole thing. So that's going to make j omega mu naught divided by sigma whole square root. So eta2 is equals to square root of j omega mu naught divided by sigma. So we have found the expression for the complex impedance. Now we go ahead and find the expression for gamma. Gamma, as we already know, which is the complex field reflection coefficient, is given by eta2 minus eta1 divided by eta2 plus eta1. So in our case, we already know what eta2 is and we already know what eta1 is. So we can make the substitution for these ones and find the expression. Okay, I'll leave that as an exercise. And then we have to find what the expression for R is equals to. So R is equals to reflected power, average reflected power divided by average incident power. We know that the average power is calculated as, using the Poynting vector, as half real part of E H, EH conjugate, E cross H conjugate. So in this case, let's find out what P incident average is. So the incident average would be, from the simplified equation, equals to E I naught square by 2 eta 1. Similarly, P reflected average would be E reflected square divided by 2 eta 1. But we know what E reflected is. E reflected divided by E incident is going to give us actually the gamma, right? So therefore E reflected is equals to gamma into e to the power incident wave. Therefore we have power reflected average is equals to gamma square E incident power, E incident square divided by 2 eta 1. Okay, so therefore reflected power is equals to P reflected average divided by P incident average, that is equals to gamma square E incident square divided by 2 eta 1 divided by E incident square divided by 2 eta 1. Everything cancels out and we are left with gamma square. So R is equals to gamma square. Being a bit liberal with the signs, it has to be mod gamma square everywhere. So because the mod gamma comes as a picture because it's the real part of the power, so that's why the mod exists. So this is how we find the expression for R. Now you can go ahead and make the substitution that gamma square is basically equal to N2, that is eta 2 minus eta 1 divided by eta 2 plus eta 1 whole square. So yeah, either you can stop here or go ahead and make the substitution for eta 2 and eta 1. That's up to you. Thank you.